Wake up! So I've added some updates to basic software. It's not Pelicam, it's just code so I can take this camera outside. My cat is at the window over there. Let's see if I can get him. But I added pan zoom using scalar crop, it's called. It's part of the Pelicam 2 library. So this is the Computer zoom lens. So let me get this in focus real quick. Aim it at my cat. There he is. So if I want to zoom in, right now it's at 1x. I tap it, zooms in 3 times. You can see his fur is in focus there. And then I can go left, back to middle, to the right, and go up, down, down. So that's the panning part. And I can go 5 times closer, like that. You see how bad the vibration is with a zoom lens? Alright, so we got that. And then there, that's in focus. And then you would just take a picture. You can zoom all the way back out. We'll take this picture real quick, which there's no shutter delay there. I added this option, shutter delay. Yeah, you gotta tap the top here. So it's on now. Then when you take a picture, it'll wait. Oh wait, do I have to click it? Yeah. Yeah, it'll wait 5 seconds. You can probably see the difference on between those 2 pictures. You can do other things like shutter speed, but I have to like watch some videos on what that means. I mean, I know you turn it up higher, like if you're shooting a moving car or something, but I need to know like the specific values to use. And then I'm also aware of like reciprocal. So it's like if you have a 50mm lens, you use 1/50 seconds. But you know, this is like a zoom lens, so 5.5 times 8, it's like 60mm, like 1/60, that kind of thing. I do need those controls because when you shoot an auto, you're kind of just like accepting whatever Pelicam 2 decides. For the most part, it's good, but you know, you don't really have control. So, alright, so I wanted to just briefly talk about the code I'm running right now, which is not Pelicam, it's just basic software. Specifically, how do I explain this? So, this is the directory of the Pi camera. It's not on right now, it's charging, but so the Pelicam directory source camera, this is the code I'm running, which you see there's a main file, and then we've got a couple folders like buttons, camera, IMU, the OLED, and then pictures that are taken go here. So, and this code is like really nasty. I just have been writing over it over time just to have something to use, because you know, I want to go out on the weekend and take pictures. And Pelicam is a big project. It's like a desktop app that you build menus with, and then you have the part that actually interfaces with the camera hardware. I did stop working on that for a bit just because I was hung up on the algorithm that traverses a nested object, but I just decided to use AI for that to move forward. And then I have yeah, so I'll be working on that again, but right now I'm just going to talk about the software I'm using, which I just demoed. So I want to talk about zoom, the pan, zoom, and cropping. So this is main on the left. We bring in those folders from camera, dock camera, import camera, which this is the class, as you see right here. And this is using the MJPEG server example to create a video stream, and then you're showing the frames through OpenCV. That's the pass-through. So when the class is initialized, you've got the PyCamera 2 right here, and you've got some values like the zoom level, offset X and Y, and there's the shutter delay too. So you set up photo configuration like for taking pictures. This is using full resolution, so the 12 megapixels like 4000 by 3000. I see right here. Then we got the video configuration, which let me see. I don't want to go into this right now, but there is a post on Raspberry Pi forums that explains how the camera modules work. But yeah, so like this is the sensor we're using, IMX477, that's the HQ cam. So it's got these different modes, and I'm using this one. It's like full screen and high frame rate. I don't think it's actually full screen, but yeah, anyway. So I've got that set up here. I'm using the 640 by 480. It's using this output size. And then you start the stream. You take that video configuration. The display size on the camera is this 640 by 480. It's a DSI display. So it's recording, and then OpenCV is running right here. This is the rendering loop. This is what it decides to show images, and that shaking thing with the anime girl, that's the inertial measurement unit sampling. There's just a thing here, which I'll talk about that later, but yeah. So here's the frame from the camera. This right here, like the output, streaming output. And then it sets the frame here. So camera output frame. So the streaming output class is set right here, output, and then when it writes the frame to itself, it's writing to that output. Anyway, that's how main is accessing the frames from the camera and showing them. And then when you're zooming in, like see zoom in right here, the touch screen has a callback. So when you click anywhere on the screen, you get the X and Y coordinate of where you just touched, and then it determines if it's going to zoom in based on like the camera active state. Camera active means the pass-through is on. So you tap the screen, it zooms in. So it zooms in over here. You start at 1, so you set it to 3, and then you do the offset, which the offset, dang, I don't have that picture anymore. The offset is like this, so 3x is like this, and then 5x is like that. You ignore the dimensions, these are wrong. But yeah, so it's like when you zoom into 1, or at the 3, you have to set the offset like 1, 1, x and y direction. It's 0 based, just because of the scalar crop, how that works. So yeah, speaking of scalar crop, this allows you to pick a specific portion of the sensor and show it based on the X and Y offset and then the size of the sample. So like when you're at zoom level 5, it's showing a small picture like 811, 608. This is based on the full resolution, this right here. So you divide 4056 by 5 and you get something like 811. And then yeah, the panning is just changing these values here, like X and Y, and then the size remains the same unless you zoom in. Every time you zoom out, it resets it back to like 1:1 or 2:2, the offset. That's the center. And then, yeah, when you take pictures, it switches modes. Like it goes to photo configuration, and then it goes back to video. But actually, the picture part is right here. It's using this switch mode and capture array. And then the IMU, I just added that. It's like a gimmick, but the camera has one. Like you can add like a horizon leveling thing if you want. Although I've done like Dead Reckoning before, but I have to implement that myself still. I have not. But this is the IMU class right here. And the one I'm using is called GY91. It's a 9 degrees of freedom, or it's 3x3, like 3 acceleration axis, 3 gyro axis, and 3 magnetometer. A magnetometer is like it's an extra thing you use for drift. But yeah, I still have to lock in my IMU knowledge. But for the shaking thing, it's very basic. Like in the sampling, it's just checking if gravity or the acceleration is more than the acceleration of gravity, which is, 9.81 meters per second squared, but here it's just considered 1. But yeah, I shook it around in my hand and I saw like 1.5 come up kind of rarely, so I was like, alright, that's a good number to hit. So then it's just showing that face, which all it's doing is taking this method right here and setting this global value right here, like show the face. And then the face is just a like anime girl face. But it's just showing you like you can make anything, Like Pelicam, you can make a cyberpunk theme or Hello Kitty theme menu, camera menu. Actually, I'm already designing like new cameras. I'm gonna make like a basic one, a slab, because this one right now this green one is like a weird shape. But yeah, and I was thinking, well, I still am thinking that it's only gonna have one button, this, the shutter. Otherwise, yeah, it's purely gonna be touchscreen. And then the display doesn't move, but the sensor moves, like it's on a hinge. That way you can like take a picture of something on the ground and look down at the screen. But whether or not that's a good idea, I don't know. But the other thing is, there's other cameras I want to build, like a video recording one that is shaped like a camcorder, where it has like that flipped out rotating display. But another one is going to have a microphone and a speaker, and you can talk to it and it'll run a small LLM locally on the Pi. It's just like a gimmick, but I don't know, that could be fun. I think it's also silly to have a full computer inside a camera, but why not, man? They're like $40. But yeah, so that's the code I'll be running today. The shutter speed thing, I don't have that enabled. I have to do that at some point. Same with like ISO, and I just gotta conceptually understand it. And then on the pass-through where you see the camera frames, you would overwrite or overlay those values, and you could like tap on them to change them. But yeah, that's just work. But I am gonna do that before Pelicam, just so I can, have a camera that I can use and not wait for Pelicam to be finished. But anyway, it's crazy how long these videos get. It's already 11 minutes. But yeah, so I'll have that, and then I'm about to go out in like an hour to the park. Hopefully I don't have blurry pictures without that shutter speed setting. Did I talk about everything? I think so. I guess I could briefly talk about the... So this method right here, this is what creates the list of images, but it also has that shutter delay thing. So I just said where it goes, and then the on-off value is based on the camera shutter delay property right here. And then when you tap on the screen, there's a thing here that checks the area that you tapped, and then it toggles that value, and then it re-renders the files image, which shows up down here if it has pictures. So yeah, that's that. The IMU is running a thread, so that's why it's not blocking the rendering of the display and the buttons. The buttons has its own thread as well, and the camera has its own thread as well, although it's using this condition thing here. Anyway, that's it. No more words.